We are on section 8.5. We're going to talk about molar mass. So molar mass is the mass in grams of 1 mole of a substance. The mass in grams of 1 mole. So the molar mass of an element, if we're just looking at nitrogen, not the diatomic molecule, but just the nitrogen, the mass of 1 mole of nitrogen atoms is 14.01. So we can say 14.01 grams per mole. Where did that number come from? It's on the periodic table. The molar mass of H2O. Well, H2O in every mole has 2 moles of hydrogen and 1 mole of oxygen. So 2 times the mass of hydrogen plus 1 times the mass of oxygen adds up to 18.02 grams per mole. Every mole of water weighs 18.02 grams. Every 6.022 times 10 to the 23rd molecules of water weighs 18.02 grams. The molar mass of something like barium nitrate. This formula is a little more complicated. Remember that this 2 means we have 2 of everything inside the parentheses. The parentheses are like shrink wrap, and each of these bundles has 1 nitrogen and 3 oxygens. So we have 1 barium. We look up barium on the periodic table. We have 2 times the mass of nitrogen, because there are 2 nitrogen atoms, or 2 moles of nitrogen in 1 mole of this substance. And then we have 2 times 3 is 6, so 6 times the mass of oxygen. You add all those up, and you get 261.35 grams per mole. You can't have a negative molar mass, and you can't have a molar mass that's less than 1 gram. Hydrogen is the smallest element, and 1 mole of hydrogen atoms weighs 1.008 grams. So if you ever come up with a molar mass that's less than 1, you did something wrong, because that's the smallest atom, and you can't have anything smaller than that. Let's calculate the mass, the molar mass of nickel 2 carbonate. So in order to calculate the molar mass, we need to know what the formula is. And we're not given the formula here, so we have to figure it out. So that gives us a little practice back from chapter 5. Nickel 2 carbonate, that's an ionic compound. Nickel 2 is Ni2+. The Roman numeral tells us the charge, not how many atoms there are. Carbonate is CO3. How do I do that? I don't know. CO3, 2 minus. Plus 2 minus 2, that means that the formula is just one of each of these. NiCO3. You have to have the formula or you can't find the molar mass. So then we look up nickel. Nickel is 58.69. 58.69 grams per mole. And then we've got carbonate. Carbon is 12.01 grams per mole. And then we have, oops, I'm running into myself here, 3 times the mass of oxygen . 58.69 plus 12.01 plus 3 times 16 equals 118.7 grams per mole. Other way to write that is 118.7 grams of nickel 2 carbonate. I did so much better in the first hour. Equals 1 mole of nickel 2 carbonate. Looks like a first grader wrote that. Oh well. Any questions? This is like taking a box of bowling balls, and you've got an 8-pound ball and two 10-pound balls and 5 11-pound balls. How do you figure out what they all weigh together in the box? You add it up, right? You say, well, I got one of these, and it weighs this much, and I've got 2 of those, so I'll multiply that by how much each of them weighs, and I've got whatever number I said of the other, and you just add them up. It's the same process here. We're adding up moles of atoms. Any questions? This is a different sort of a question. Consider equal mole samples. What does equal mole mean? Does it mean they all have the same mass? No, they all have the same number of particles. So we're saying we have the same number of each of these. Doesn't say what number that is, but it's the same. So we've got N2O and AlNO33 and KCN. It says rank these from least to most number of nitrogen atoms. Well, let's look at these individually first. N2O. One mole of that has how many moles of nitrogen atoms? 2. Or you can think of it, one molecule of N2O has how many nitrogen atoms? 2, right? 2 moles. That's the same as saying one molecule of N2O has 2 atoms of nitrogen. Does this line make sense to everybody? You have to move your head. Up and down means yes. Side to side means no. Good enough. So one molecule. When we go to moles, I lose a lot of people. So I want to make sure that you understand what mole means. Well, let's do clovers. There's a clover. 3-leaf clover. If I have 2 clovers, well, no, let's just make that one. In one clover, singular, I'm making this up, can you tell? Giggle, giggle. One clover has how many leaves? 3 leaves. We're like, duh. She's lost her mind. 1 dozen clovers have how many dozen leaves? 6. No. A dozen clovers, how many dozen leaves? 3 dozen. The person who said 6 just has a brain fart. Okay? 3 dozen leaves. If I had a ream is 500. If I had a ream of clovers, how many reams of clover leaves would I have? 3. If I had 1,000,000 clovers, how many million leaves would I have? 3 million. These are all counting units. If I had a mole of clovers, how many moles of clover leaves would I have? 3. Do you see that? I'm getting blank stares. Very, very blank stares. But you're okay with this, right? 1 clover is 3 leaves. If I multiply this by 12, and I multiply that by 12, which I can't seem to do, is it still equal? If I take a mathematical equation and I do the same thing to each side, let's maybe back up even more. I've got a teeter-totter. They don't have those in playgrounds anymore because they're dangerous, right? You could hurt yourself. And I have one box on each side, and it's balanced. So nobody has a problem with that. That's good. What am I looking for here? Well, fine. If I put, what? Come on, I just want to change the color. Okay, we'll change the shape instead. Fine, whatever. If I put a yellow circle on that side, is it balanced? A yellow circle. If I put a blue circle on that side, is the teeter-totter balanced anymore? No. I have to do the same thing to the other side, right? Let's see if I can... What? I don't know what it's doing to me. It's torturing me. There we go. Okay, so it's not in quite... So I have to do the same thing to each side for it to be balanced. The same thing with a chemical equation or a mathematical equation. So if I have 1 clover is equal to 3 leaves, then if I multiply that by 12, on both sides it's still the same. 12 is a dozen. If I have 1 clover, I have 3 leaves. If I have a dozen clovers, I have a dozen leaves. If I have 1,000,000 clovers, I said that wrong. Yeah. If I have that's good. That's very good. If I have a dozen clovers, I have 3 dozen leaves. If I have 1,000,000 clovers, I have 3,000,000 leaves. Whatever that word is in the middle there, whatever this word is, dozen, as long as it's the same on both sides, those are units that just multiply by a number. A mole is like a dozen, but instead of multiplying by 12, it multiplies by a really weird number. So, back to what we were originally talking about. I don't know if that helped or not. But 1 molecule of N2O has 2 nitrogens and 1 oxygen. So 1 molecule has 2 atoms of nitrogen. So if I multiply that, if I just change this from an individual number to a counting number that's bigger, then 1 mole of N2O has 2 moles of N2O. Why didn't somebody, you guys tell me? Is that better? That's, God. Okay, I'm sorry. Yeah, that would be confusing.
I thought that was supposed to be different.
How much sleep did you get last night?
Not enough. Obviously, I did not get enough sleep last night.
Did you have a very right?
But now I do.
So let's do this again with donuts, okay? The problem with doing it with donuts is that donuts don't have parts.
You use donut holes.
No, it's the concept.
It's the concept of the 1 to 12. A bear.
I was just trying to help out a little bit.
How about I did clovers because we could do Oreo cookies. Yes. Okay. So Oreo cookies, you have the 2 cookies and you have the stuff. Right? Okay. So if you have one if you have one Oreo, how many cookies do you have? The black part. You have 2 of, what should we call those? The black part. 2 black parts. Because we don't want to confuse the whole cookie with the 2 cookie parts. And if you have one Oreo, you have 1 piece of stuff. Well, actually, it's not piss. Just it's stuff with. It's stuff with 1 F, because the double stuff. What's double? It's the white stuff in the middle. That's the official name for the frosting between the 2 cookies. It's stuff. So there's 1 piece of stuff. Well, no, it isn't actually double. It's just more stuff. But more stuff doesn't make a good name for a cookie. Well, yes, if you're going to say double, you should do double.
The science class did that as an experiment.
Yes. Well, yes, 1 Oreo does equal 2 black parts and 1 piece of stuff. But if we're not interested in the stuff, in 1 Oreo you have 2 black parts, correct? In 1 Oreo you have 1 piece of stuff. Okay? So if I had a dozen Oreos, how many dozen black parts? 2. Okay, so this is better than Clover's. 2 dozen black parts. If I had a mole of Oreos, how many moles of black parts would I have? 2 moles. 1, that's singular. 1 mole of Oreos, that's an O.
See, there's a reason for your bet. We'll apply it.
Yeah. Of course, the YouTube people missed the whole story about why Oreos came up, but that's okay. That's the perks you get for hearing this live. So those chemical formulas tell us the relationship between the number of atoms of each element. N2O, there's 2 nitrogen atoms and 1 oxygen atom. If we have a mole of N2O molecules, then we have 2 moles of nitrogen atoms. Okay, so let's get rid of all that so that we can actually do what we're supposed to be doing here. So if we have 1 mole, I'll do it right this time, I promise. 1 mole of N2O, we're going to have 2 moles of N. Right? Everybody? Is that right this time? Good grief. Okay, if I have 1 mole of aluminum nitrate, how many moles of nitrogen in that? 3. Somebody said 1. Okay, aluminum nitrate, there's a 3 outside this. This is the shrink wrap, and inside this bundle pack there's 3 oxygens and 1 nitrogen. So there's 3 nitrogens in each molecule, so there's 3 moles in each mole. And I screwed up again. You guys need to tell me about this. There. I might have to do this one over at home. 1 mole of KCN has how many moles of nitrogen? 1. All of this work for 1 stupid exercise. Hopefully we're learning something, though, other than Tommy likes Oreos. So if I had equal mole samples of these three compounds, which of these would have the least number of nitrogen atoms? The KCN. So KCN is the least. Which one has the middle amount? The N2O. And which one has the most? The aluminum nitrate. Any questions? Does it make sense now? Oh, good. Because that was painful for me. 20 minutes.